Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Today we will be discussing about the rules about unsaturation present in an organic compound. So let's begin. If double or triple bond is present in the longest chain, then all the rules that you learned in my last videos will be followed. The only difference is to add suffix "-ene" for double bond. For example, this one is hep2-ene because double bond is present at carbon number 2 in this compound. For triple bond, you will have to add "-n" showing its location with the number of carbon at which that triple bond is present. For example, here is the compound. The name of this compound is oct1-n because triple bond is present at carbon number 1. So you learned that suffix "-ene" is used for double bond and suffix "-n" is used for the presence of triple bond in the organic compound. And also you learned that the locant is added just before the suffix "-ene" or "-n. These are the locants. 2 is the locant here for the double bond, and 1 is the locant here in this compound for the triple bond that shows the position of that triple bond. If it contains both double and triple bonds, then you will have to use the suffix "-ene" and "-n". "N" is the position of the double and the triple bonds respectively. For example, here is a compound that contains both double and triple bonds. So how will you name this compound? The name of this compound will be written as oct3-ene-1-n. So here 3 shows the position of the double bond which is present at third carbon, that is 1, 2 and 3. So this double bond is at position number 3. This locant shows this position, and then 1-n means that triple bond is present at carbon number 1. Remember, "-ene" comes before "-n" because they are placed alphabetically. In case of more than one double or triple bonds, then you will have to repeat the locant, that is "n, n", and also you will have to add the prefix that shows the multiplicity of the double or the triple bonds. For example, "nn-di-ene" or "nn-di-n". N is always the locant of the multiple bond. For example, here is a compound which has 2 double bonds and 2 triple bonds. The name of this compound will be dic3,5-diene-1,9-di-n. This 3,5 shows that one double bond is at position number 3, 1, 2, 3, and another is at position number 5. Similarly, the 2 triple bonds are located at position 1 and 9 respectively. The actual problem arises when there are more than one chains. In this slide, I showed you all the examples that contained only one chain. So there was no problem of selecting the parent chain because there was only single chain and that was our parent chain. What about if there are more than one chains in the organic compound? The parent structure is the longest chain irrespective of the double bonds. That is, you will have to select the longest chain as your parent chain, while according to previous IUPAC rules, you will have to select the chain that contained the double bonds or triple bonds. But here in new rules, you will have to select the longest chain, not the one that contains the double or triple bonds. For example, here is the compound. This is the longest chain and it is our parent chain. Why is this the longest chain and our parent chain? Because it contains more number of carbon atoms as compared to the chain with the double bond. Let's see. This chain contains 1, 2, 3, 4, 5, 6, 7 carbons, while this chain has 1, 2, 3, 4, 5 and 6 carbons. According to previous IUPAC rules, you would have selected this chain as your parent chain because it contained double bond. But according to new rules, this will not be our parent chain. Our parent chain will be the longest chain here, and this will be the branch. So the name of this compound will be 3-methylidene heptane. Heptane is our parent chain and 3 is the position of the branch that is attached to the parent chain, and methylidene is the name of the branch. If 2 chains have similar length, then follow the following steps. In case of similar length, select the chain that contains multiple bonds. For example, this is a compound given. It has 2 chains of similar length. This is chain number 1 and this is chain number 2. Both of the chains have 9 carbons in them. In this case, we will not select this chain which doesn't contain the double bond. We will have to select the chain that contains the unsaturation. That is, this will be our parent chain. So this is the parent chain and the name of this compound will be 3-ethyl-none-1-ene. 3 shows the position of the ethyl group that is attached at carbon number 3 on the parent chain. 1 is the position of the double bond, which is here in the parent chain. What if one chain has double bond and the other chain has triple bond? Then you will have to select the chain with double bond, not the triple bond. For example, this is a compound. It has 2 chains, one with double bond and another with triple bond. Both of the chains have same length. So now the competition is between the double and the triple bond. Here you will have to select the chain with double bond, not the one with the triple bond. The name of this compound will be 5-but-3-1-1-L-dic-1-ene, and this 5 shows the position of the branch. This is our branch in this case. As this is a complex branch, that's why we have enclosed this branch inside parentheses. This 3 shows the position of the triple bond in the branch, and this 1 shows the carbon number of the branch that is attached to the parent chain. This 1 shows the position of the double bond in the parent chain. Now what if one of the chain has one multiple bond and the other one has more multiple bonds? Then you will have to select the one with more multiple bonds. For example, this is a compound. It has 2 chains. One chain has one multiple bond and another chain has 2 multiple bonds. Here you will have to select this chain as your parent chain because it contains 2 multiple bonds as compared to this chain which has only one double bond. So this will be our parent chain and this will be considered as branch. The name of this compound will be like this. Here this 5 shows the position of this main branch. As this is a complex branch, that's why we have enclosed it in parentheses. This 3 shows the position of double bond in the branch. So this is the double bond and it is at position number 3. 1, 2, 3. This 1L means that carbon number 1 of the branch is directly attached to the parent chain. This 3 shows the position of the double bond in the parent chain, which is here 1, 2, 3. And this 1 shows the position of triple bond on the parent chain, which is this carbon. What about if both the chain has same number of multiple bonds? Then you will have to select the chain with more double bonds. You will have to give preference to double bonds in that situation. For example, this is a compound. Here in this compound, one of the chain has 2 double bonds and another chain has 1 triple bond and 1 double bond. Both of the chain has same number of carbon atoms and same number of multiple bonds. But one chain has more double bonds as compared to the other chain. So you will have to select this chain because this contains more number of double bonds. And the name of this compound will be written like this. Here in this compound, this 1 shows the position of double bond inside the branch, which you can see it is here at position number 1 in branch. This 3 shows the position of triple bond in the branch. So 1, 2, 3. This 1 shows the carbon that is attached to the parent chain. This 1 and 3 shows the position of double bonds inside the parent chain, which are 1, 2 and 3. So 1 and 3. If both the chains have same number of same kind of multiple bonds, then number both the chains, select the one that has lower locant for unsaturation. For example, in this case, you will have to select this chain because if you number this chain, then it will be 1, 2, 3, etc. So the double bond position will come at position number 1. While in this chain, the position of double bond will be at carbon number 2. 1, 2. So you will have to select this chain. If you see, all other conditions are same for both the chains. Both of the chains have same number of carbon atoms. Both the chains have same number of multiple bonds. Both of them has same number of double bonds. But the only difference is that in one chain, the position of double bond is at carbon number 1 and in another chain, it is at carbon number 2. So you will have to select that parent chain which has the lower locant for the position of the multiple bond. So this will be your parent chain. If still there is a tie, then you will have to select that chain that has maximum number of substituents and follow the rules as described in previous videos for alkanes. Okay, now numbering the parent chain. Give the multiple bond the lowest possible number regardless of substituent placement. Like this, 1, 2, 3, 4, 5. You will not start numbering from this side. You will have to start numbering from the position of multiple bond. If double bond is present from one end and triple bond from the other end and they are at the same position, for example in this compound, you can see that from this side double bond is at carbon number 1 and from this side triple bond is at carbon number 1. then number the chain from the end closest to the double bond, that is from this side. So the numbering will be starting from double bond side. If same kind of bonds from both ends, for example in this compound, here double bond is from this side and double bond is from this side, and both of them are present at the same position, then look for the next closest multiple bond and so on. As you can see, the next closest double bond is from this side. That's why we have numbered the chain from this side. If with respect to multiple bonds, everything is same. For example, in this compound, here double bond is present at position number 1 from this side and double bond is present at position number 1 from this side as well. Then you will have to look for the closest substituents, means follow the rules for alkanes mentioned in my previous videos. So the numbering will start from this side because substituent is closest to this end of the parent chain. The name of the first compound will be 4-methyl-pent-1-ene. The second compound will be non-1-ene-8-ene. The third compound name will be deca-139-triene, and this compound will be named as 3-methyl-deca-1,9-diene. If unsaturation is present in a ring, then please watch my previous videos. The link for the previous video is given in the description sections. And also learn the rules for alkanes, cycloalkenes, alkenes and alkynes, because most of the rules are the same for unsaturated rings. After you have selected the ring as your parent using the rules mentioned in my previous and this video, add prefix cyclo to the parent name. Indicate double bonds with ene and also show its locants. Number the ring from carbon of double bond. Move along the double bond toward another double bond or closest substituent. For example, this is a ring compound with a single double bond. The name of this compound will be cyclopentene. Because this ring contains 5 carbons and only 1 double bond, that's why you don't need to show the position of that double bond. This compound has 2 double bonds and it has 5 carbons in its ring. The name of this compound will be cyclopenta-1,3-diene. One of the double bond will be present at carbon number 1 because you will have to start from this carbon or from this carbon. If you start from this carbon, 1, 2, 3, the next double bond will be at carbon number 3. You cannot start numbering from here 1, 2, 3, 4 because then next double bond will come at 4th position. Now what about this compound which has got 1 double bond and 1 substituent? The name of this compound will be 3-methyl-cyclopentene. No position for double bond because you will have to start from the carbon of the double bond, that is 1, 2 and 3, and methyl group is at position number 3 of the ring. What about this compound? It has got 2 substituents and 2 double bonds. The name of this compound will be 2-bromo-5-methyl-cyclohexa-1,3-diene. Here you will have to start from this carbon of the double bond and lead towards another double bond. So 1, 2, 3, 4 and 5. So bromine will come at position number 2. This methyl will come at position number 5. And these 2 double bonds will get their lowest locants, that is 1 and 3. If we go from this carbon, then 1, 2, 3, 4, then this double bond will get a higher position. That's why we do not start from this carbon. What about unsaturation in a branch? All the rules for the branch are the same that you learned in previous as well as in this video. The only thing is to add "-ene" or "-yen" before "-yel" in the branch name. For example, this is a compound. Here this is our parent chain which contains 8 carbons while this is the branch. So how will you name this branch that contains a double bond? The name of this compound will be 4-ethinyl octane. Here you will have to add this "-ene" for this double bond in the branch. What about this compound? The parent chain in this compound is again the same. It has got 9 carbons in this parent chain. This is the branch which has got 3 carbons and a single double bond in it. The name of this compound will be like this. Here this 5 shows the position of the branch to which the branch is attached to the parent chain. This 1 shows the position of this double bond and this "-ene" is the double bond. What about this compound? Here this is our parent chain which has got 9 carbons and this is a complex branch now. So the name of this compound will be like this. This 5 shows the position of the branch. These parentheses show that the branch is a complex one. This 3-yen shows the position of the triple bond in the branch. So this is the triple bond and it is at position number 3. That is 1, 2 and 3. This 2 shows the carbon that is directly attached to the parent chain. So this is the carbon number 2 of the branch. 1, 2. This is the carbon number 2 in the branch which is directly attached to the parent chain. That's why 2L. If there is a double bond between branch and the parent chain, then use Yelidine instead of Yel as branch suffix with its locant if necessary. For example, this is a compound in which this is our parent chain and a single carbon is directly attached to the parent chain with double bond. So this is our parent chain which contains 8 carbons. The name of this compound will be 4-methylidine octane. Here you can see we have not used only Yel, it is Yelidine. So the name of this is not like 4-methyl octane. It is 4-methylidine because this branch is attached to the parent chain with double bond, not with single bond. What about this compound? It has got 2 carbons in its branch that are attached with double bond to the parent chain. This is the parent chain which has got 8 carbons in it. The name of this compound will be 4-ethylidine octane. This is ethyl because it has got 2 carbons, and this is Yelidine and it is attached at 4 number carbon at the parent chain. What about this complex branch? This is the parent chain in this compound and the name of this compound will be like this. This is a complex branch, that's why we have enclosed it in parentheses. This but shows that there are 4 carbons in the branch. This 2-Yelidine shows that carbon number 2 of the branch is attached to the parent chain. And Yelidine shows that there are 2 bonds between branch and the parent chain. What if there is a double bond in the branch as well as a double bond between parent and the branch? For example, in this compound, this is the parent chain. The name of this compound will be 4-ethenylidine octane. Here, this ene shows this double bond and this Yelidine shows this double bond. 4 shows the position of the branch at the parent chain. What about this compound? Here, this is the parent chain which has got 9 carbons in it. And the name of this compound is written like this. Here, this 5 shows the position of the branch at parent chain. This 5. This prop shows that the branch has got 3 carbons. 1 ene shows the position of the double bond in the branch. This is the double bond and it is carbon number 1, 2 and 3. The position of double bond is at carbon number 1 in the branch chain. This Yelidine shows that there are 2 bonds between parent and the branch chain. What about this complex branch? This is our parent chain which has got 9 carbons. The name of this compound will be written like 5-but-3-N-2-Yelidine nonane. Because this parent contains 9 carbons, that's why the name of the parent will be nonane. This 5 shows the position of this branch which is attached at carbon number 5 at the parent chain. This but shows that there are 4 carbons in the branch. 1, 2, 3 and 4. This 3N shows that there is a triple bond at position number 3 in the branch. 1, 2, 3. So at position number 3 we have got a triple bond in the branch. So 3N. What about 2-Yelidine? This Yelidine shows that branch is attached to the parent chain with a double bond. And this 2 shows that carbon number 2 of the branch is attached with the parent chain. Now let's come towards the geometry of the double bond. Double bonds can exist as geometric isomers. These isomers are designated by using either cis-trans designation or the modern ZE designation. E means that priority groups are on the opposite sides, while Z means that priority groups on the same side. If double bond is present and you want to show the geometry of the double bond in the IUPAC name, then write the position of geometry of all the double bonds, where you will have to show these positions before the name of the compound. And how you will show those positions? You will have to enclose them in parentheses with the locants of the double bond. For example, here you can write the name of these compounds as cis-2-butene. This cis shows that 2 similar groups are on the same side, while this trans-2-butene means that 2 similar groups are on the opposite sides. So cis or trans will be written before the name of the compound. Or you can also use this modern nomenclature, that is Z or E, and you will have to enclose them in parentheses. So Z2-butene, because 2 priority groups are on the same side, while in E2-butene 2 priority groups are on the opposite sides. And in this situation you can see we have got 2 double bonds in both of these compounds. So you will have to show the geometry of both these double bonds before the name enclosed in parentheses. Here in this compound, one of the double bond has the geometry of E and another has the geometry of Z. The geometry of double bond that is at position number 1 is that it has two priority groups on opposite sides, while the geometry of the double bond which is at the position number 3 has two priority groups on the same side. While in this compound, both of these double bonds have the same kind of geometry, that is Z, in which priority groups are present on the same sides. You will have to show the geometry of the double bonds before the name enclosed in parentheses, showing the locants as well as the Z and E nomenclature. So that was all for today. Thank you. Allah Hafiz.